Hi, and welcome. I'm Amit Gohil, and today I'm going to walk you through the Synopsys Functional Safety Test Solution architecture. Designers of automotive SoCs can integrate this automated end-to-end BIS solution to accelerate ISO compliance and their time to market. This is an instance of SMS SHS Safety Solution architecture, where we have SMS IP for memories, SHS wrappers for all user IPs such as DDR and PCIe, and SMU, which is a clock and memory monitoring Synopsys IP. This diagram shows Safety Manager, which in this instance is a Synopsys ARC processor, connected to the top-level server via Safety Bus. On PowerUp, you can invoke the Smart Mode to run a predefined set of test and repair sequences using the SMS server. The server then hands control over to the Safety Manager. The Safety Manager processor allows the user to create post and mission mode tests via firmware. As part of SHS, Synopsys also provides SMU IP, which can be used to measure clock frequency, duty cycle, memory performance, and the trend of transistor aging. This is the demo architecture we will show today. It's running on an ARC-EM software development platform. The design contains ARC-EM4 as Safety Manager connected to a server with 2 SMS processors and the SMU IP, which will measure the clock. We have 3 rings of serially connected IP using IEEE 1500 or IEEE 1687 interfaces. We will manually inject errors using the fault injection function on SMS2. This is the dev board containing the ARC-EM4 processor connected to some SMS wrapped memories. I'll be injecting the memory errors by setting these switches. Let's jump to the demo. I have slowed down the firmware by injecting large artificial delays. You can see the status of SMS1 and SMS2 in the top 2 boxes. Now, I will manually inject an error using the switch on the dev board. I can inject different kinds of memory faults using the switches on the development platform. I have injected the fault, and now you can see that the SMS2 fails the memory BIST. In a real application, the BIST will be running in the background periodically for a short period of time. These tests can run in parallel to test many memories and IP concurrently, as you can see here. The SMS1 and SMS2 run and stop in parallel, shortening the BIST time in about half. The third box here shows the SMU status. The SMU IP is an SHS wrapped IP that can measure clock frequencies, duty cycle, memory read delays, and chip aging. Currently, it is periodically measuring the clock frequency, which is a very stable 50 MHz and a 50% duty cycle. Now let's talk about the YA tool that helps you generate firmware quickly. Synopsys YA tool is part of the full safety solution. With YA, users can take JTAG patterns that access the SMS SHS IP and generate a compressed and efficient C-based firmware code. The code can run as post and/or periodic mission mode test. The YA tool also lets you design a very sophisticated parallel pattern execution flow that allows you to speed up testing and take action when something fails. These failures can be viewed using YA firmware diagnostics feature. Let's see how that looks. This is Yield Accelerator, where you can generate patterns to target SMS and SHS wrapped IP and generate firmware. In this left pane here are the patterns that can be configured by the DFT engineer or the production engineer. Once the DFT engineer has configured the patterns, they can generate firmware by pressing the firmware button. Yield Accelerator can be configured to generate all code necessary to run on the Safety Manager processor. You or your team will need to fill in some code to enable and run the MCU timers and set up a way to dump the diagnostics array into a file. Once these functions are defined, you can run the firmware and see the results in the YA diagnostics view. Thank you for joining me today to learn about the Synopsys DesignWare IP Functional Safety Test Solution. If you'd like more information, please reach out to me or visit synopsys.com. Thank you.